We're back.
We are.
Episode 2. Tell our viewers what we're going to see.
Well, in the first episode, as you know, we talked about the why SD-WAN. In this episode, we're going to be looking at how it kind of works from a generic perspective. So it's very much looking at the anatomy of SD-WAN. We'll explore the definitions, the de facto standard definitions out there, and also perspectives from key players like Gartner, for example. What are the kind of classic characteristics of a great SD-WAN solution? What should customers and those that deploy this technology, what should they expect to see as characteristics of SD-WAN? That's our focus in episode 2.
Cool. You ready to go?
Absolutely, my friend.
Let's go.
So here we're going to consider how. How does generic SD-WAN work from an architectural perspective? To begin with, here are some industry perspectives. Network World suggests SD-WAN is a software approach for managing WANs. It offers ease of deployment, central manageability, and reduced costs, and can improve connectivity to branch offices and the cloud. While our friends at Gartner says SD-WAN, it's a mainstream technology that offers several benefits compared to traditional router-based WANs. IT and operations leaders responsible for planning, sourcing and managing WANs can improve agility, increase uptime, reduce costs by using SD-WAN products. They go on to say you've got to support multiple connection types. It can do dynamic path selection, provide a simple interface for managing WANs, and it must support VPNs. Now, everyone agrees SD-WAN is a good thing, but in reality, the market simply hasn't coalesced enough to provide a proper answer yet. And as a good thing, we can agree that it's a type of networking technology that simplifies the management and operation of the wide area network by separating the network hardware from its control mechanism. Effectively, it's software-defined networking, or SDN, but in this case, for the wide area network. Now, SD-WAN works by using software-defined policies and rules to dynamically route network traffic over the most appropriate connection, based on factors such as application type, network performance, and security requirements. Now, at a high level, the SD-WAN architecture consists of 3 main components: edge devices, a centralized controller, and orchestration software. Let's take the first, edge devices. These are located at the network edge, typically at branch locations, and are responsible for actually forwarding network traffic. The centralized controllers, well, they're the brains of the SD-WAN network. They communicate with the edge devices to collect information about network traffic, performance, and security, and uses this information to make real-time decisions about how to route and prioritize traffic. The controller also provides a centralized management interface for configuring and monitoring the network. Now, orchestration software is used to automate the deployment and the management of the whole SD-WAN network. It provides a high-level abstraction of the network topology and allows administrators to define policies and rules for traffic routing, prioritization, and security. Now, when a device on the network, like your smartphone or laptop, needs to send data, the LAN network will switch or route the data to the nearest edge device. And then this edge device inspects the data packet and determines which connection is the best path for that traffic, based on current network conditions and the current policies and rules defined by the controller and the orchestrator. The edge devices then, typically, encrypt the data and send it over the selected connection. Now, the controller will continuously monitor the network and then adjust the policies and rules as needed to optimize network performance and security. So, SD-WAN provides organizations with a more flexible, efficient, and secure network infrastructure that can adapt to the demands of a rapidly changing business environment. By dynamically routing traffic over the most appropriate connection, SD-WAN can improve network performance, reduce costs, and provide a better user experience for applications and services. In SD-WAN, network traffic and control functions are separated into different logical planes. Known as data plane and control plane abstraction, this separation allows for a greater flexibility, scalability, and efficiency in managing and optimizing network performance. The data plane, well, it's responsible for actually forwarding network traffic from one location to another. And it's implemented in the SD-WAN edge devices. And it's considered the fast path of the network as it handles the actual transmission of the data packets. The control plane, on the other hand, is considered the slow path of the network as it handles more complex functions such as policy enforcement, security, and application optimization. It's responsible for managing the network and making decisions about how network traffic is handled and is implemented in the centralized controller and orchestrator, which then communicates with each edge device to collect information about current network traffic, performance, and security, and uses this information again to make real-time decisions about how to route the traffic and prioritize that traffic. So, for example, say you're a retail organization and there is some kind of congestion happening on the WAN. You can prioritize the point of sales application to keep those tills and cashiers running optimally. They'll get their bandwidth objective, the objective they need to run optimally. At the same time, to make that bandwidth available to the more important applications, you can constrain the less important ones, such as, I don't know, employees, say, casually using social media. By separating the data plane and the control plane, SD-WAN enables organizations to make these changes to the network without unnecessarily disrupting important network traffic. If a new policy needs to be implemented, the controller can push the update to the edge devices without interrupting the flow of network traffic. This also makes it easier to scale the network, as new edge devices can be added without requiring extensive reconfiguration. Data and control plane abstraction in SD-WAN is a key factor in making the network more flexible, efficient, and responsive to changing business needs. Virtualization refers to the creation of logical or virtual network functions that can be implemented and managed independently of the physical network infrastructure. Why? Well, it allows for greater flexibility, scalability, and agility in managing the network, as well as cost savings and improved resource utilization. Now, as examples, a VSN, a virtual services network, or maybe a VLAN, a virtual local area network, these are both networking technologies that use virtualization to segregate and manage network traffic. Now, a VLAN is a widely used networking technology that logically separates devices within the LAN, the local area network, based on, I don't know, their function, their department, their location, but regardless of the physical connections. Now, VLANs use IEEE 802.1q as a standard to tag the traffic, to identify and segregate the traffic between different VLANs. And this helps to reduce broadcast traffic, enhance security, and improve network performance. However, VLANs are generally limited in scalability, and as the network grows, managing and configuring VLANs across multiple devices, they can get very complex. By contrast, VSNs is a term used specifically in the context of Extreme Networks Campus Fabric. It creates virtual networks within the campus fabric to provide better organization, security, and management of network resources. They are flexible and can easily scale across large environments, including multiple switches and routers, and they simplify network management by allowing administrators to manage multiple virtual networks as a single entity. This helps to reduce complexity and improve overall efficiency. Now, as examples of virtual technologies, VSNs and VLANs both serve to segregate and manage network traffic, but VSNs are specific to Extreme Networks Campus Fabric and offers much better scalability and simplified management compared to traditional VLANs. Interestingly, Extreme Campus Fabric can be optionally integrated into ExtremeCloud SD-WAN solution to support a flexible backhauling strategy. We'll talk more about that in a later episode. One way virtualization is implemented in SD-WAN is to use virtual network functions, known as VNFs. Now, these are software-based versions of traditional network functions, routers, firewalls, load balancers. And these can be deployed and managed as virtual instances on top of physical hardware. By decoupling the network functions from the underlying hardware, VNFs allow for a more dynamic provisioning and configuration of these network resources, as well as faster deployment and much easier scaling. Now, there's another way virtualization is implemented in SD-WAN, and this is using virtual private networks, or VPNs. VPNs allow for secure communication between different network locations by creating a secure encrypted tunnel between them. Virtualization in SD-WAN enables organizations to create a more flexible, scalable, efficient network infrastructure that can adapt to changing business needs. It also allows for better resource utilization and cost savings, as virtualized network functions can be scaled up or down on demand, and the need for physical hardware can be reduced. SD-WAN can be completely independent of the transports, the underlay, by using software-defined policies and rules to dynamically route traffic over the most appropriate transport, based on factors such as the type of application, the performance of the network, and the requirements related to security and compliance. Now, this allows organizations to take advantage of the strengths of each underlying transport technology, such as the reliability and quality of services such as multi-protocol label switching, MPLS, or the cost-effectiveness of using the internet, while also providing the ability to add and remove transports as needed. You want a bit of 4G, 5G? Go have it. The transport independence of SD-WAN provides several benefits. By routing traffic over the most appropriate transport, SD-WAN can optimize the performance of the network and reduce downtime. By using less expensive transports such as broadband or 4G, 5G, organizations can reduce the cost of their network infrastructure. And by supporting multiple transports, SD-WAN provides greater flexibility in network design and deployment, as well as the ability to adapt to changing business needs by channel bonding and load balancing. And by using a centralized controller and orchestrator, SD-WAN can simplify network management and reduce the need for manual intervention. Transport independence is another key feature of SD-WAN that enables organizations to create a more flexible, efficient, and responsive network infrastructure that can adapt to the demands of a rapidly changing business environment. Orchestration is a key feature of SD-WAN, as it allows network administrators to automate many of the tasks associated with managing a complex network and to deploy new sites or services quickly and easily. SD-WAN orchestration is typically implemented through a centralized management platform, which provides a single interface for administrators to configure and manage the entire network. This management platform allows administrators to define policies, define rules for traffic routing, prioritization, and security, and to apply these policies to different groups of network traffic or devices. Using the management platform, administrators can quickly and easily deploy new edge devices and configure them to connect to the network and communicate with the centralized controller. The management platform can be also used to monitor network performance, to monitor security and compliance, and to generate reports and alerts as needed. Now, just like a conductor of an orchestra skillfully manages multiple musicians and their instruments to play a beautiful, complex Mozart overture. One of the key benefits of SD-WAN orchestration is to allow administrators to similarly manage the network also as a whole rather than as a collection of individual devices or connections. Now, this makes it easier to optimize network performance, to optimize security, and to quickly adapt the network to changing business needs. And by automating many of the tasks associated with managing a complex network, SD-WAN orchestration allows organizations to focus on their core business activities, whatever that might be, making widgets, delivering services, etc., rather than on managing their network infrastructure. SD-WAN can also improve the performance of applications, and it can do it in a number of ways. As we all know, you cannot manage, control, nor secure what you can't see. And SD-WAN provides administrators with centralized visibility of network performance and, crucially, application usage. And this visibility can help to identify performance bottlenecks and to troubleshoot issues more quickly, improving the overall performance and security of the network and the applications running over that network. It can then use application-aware routing to steer traffic over the most appropriate network path based on the type of application and the requirements for performance and security. This can help to reduce latency, delay, and packet loss, and to ensure that high priority traffic is given priority over the lower priority traffic. So, for example, if a primary internet connection becomes congested, SD-WAN can automatically steer traffic over a secondary MPLS connection that has available bandwidth. Alternatively, if a link experiences high packet loss, SD-WAN can reroute the traffic over a more reliable connection to ensure that the application performance is not impacted. SD-WAN typically uses QoS, or Quality of Service. Uses QoS policies to prioritize certain types of traffic, such as voice or video, over other types of traffic, to ensure that real-time applications receive the bandwidth and the delay requirements that they need to function effectively. As mentioned earlier, it can also channel bond by combining multiple network links, such as MPLS, such as broadband, and create a single high bandwidth connection to increase the overall throughput of the network and reduce the network's latency. And SD-WAN can also use a variety of WAN optimization techniques, such as deduplication and compression. And this helps to reduce the amount of data that needs to be transmitted over the network. Now, this can help to reduce the amount of bandwidth required and to also improve application performance by reducing delay, latency, and packet loss. Now, clearly, by using software-defined policies and rules to dynamically steer traffic, prioritize applications, optimize network performance, and by helping to drive the adoption of direct-to-internet, or DTI, SD-WAN helps organizations deliver a far better user experience and offer a more flexible, cost-effective, and scalable architecture to help organizations maximize the value of their network infrastructure. Well, thank you for watching episode 2. In this episode, we considered the how. How does generic SD-WAN actually work? And the kind of benefits that it can provide. I look forward to seeing you in the next episode.